so this is our setup. So first I'll talk about the basic, maybe I should put it right here so you guys can, so Hannah can see everything up close. Yeah, so you guys interrupt or whatever, I'll just sort of talk about. So the general thing is if we're doing this as a activity, or you guys could do this as an activity right here in this room, you could do it like once a week or once a day or whatever the heck you wanted to do. So all this stuff is non-toxic, so there's nothing poisonous or whatever. We sometimes, depending on, like if we're doing deep sea plastics or things that are really like clay-rich soils, there's some extra things that we use that sometimes get a little toxic, but all this stuff that we have here and that you'll use. You guys are welcome to join us if you want. We're just doing a little demo thing.
I think we're good right now. Thank you.
Okay, cool. Is all non-toxic. So little kids can be around it, babies can be around it, you guys can be around it, it's no problem. The only thing is it's salt water, so you just gotta be careful with the electronics, like if you spilled some stuff. And again, historically we've done this without microscopes. Historically we started doing this with hand lenses. So we do all this and then have hand lenses, and then we progressed to maybe like 6-7 years ago having some of the sort of like macro lenses on like iPads and stuff, and then we would sort of do that. This is way nicer because it's a microscope, but instead of having one kid looking at it or one person looking at it, like 5, 6, 7 people can look at it, and you guys can also plug this into HDMI it in there. So if you wanted to do one and illustrate it for all the kids or whatever. Okay, so what do we have? So the parts we have, and you guys chime in because these guys have done it now a few times, so they're becoming experts. So okay, so all we have is we have a glass mason jar. So something to, and again, also before I start, as much non-plastic as we can get is great, but there's plastic in all this stuff in some way, shape, so don't kill yourself, right? But it's nice. You don't have to explain to people if you have a glass jar, like, okay. But a lot of times, for example, we'll pick up we'll sample our sand in Ziploc bags. And people are like, oh, that's a plastic bag. And again, we can see the signal of the bag with our chemical sensor, and there's very little leaking. Compared to what's in there, there's very little leaking. But philosophically, hey, yeah, we should use a paper bag. We should do all this kind of stuff. So anyway, so this is just a mason jar, simple glass mason jar. And then, do you guys have the salt? Oh yeah, but do you have I just want to show them the box. So you can use any kind of salt that you want, and regular salt's fine. We use kosher salt, and so that's because of the kosher standard, it's a higher quality. So we tend to have fewer microplastics when you buy this stuff off the shelf. Again, when we do it in the lab, every single thing has plastics. So when we make our own salt, we then filter it several times before we use it in the lab. You guys don't need to worry about that for a demo purpose. So the basic idea is going to be, we're going to take the sand and we're going to do a density separation. And so about 95% of our plastics that we manufacture are buoyant, will float. Not all. There's some things that are really dense that actually sink. So we miss those in this protocol. But the vast majority of all the plastics we make is mostly floaters. So the basic idea is to put the sediment in here, and again, if we're doing it as a monitoring program, we want to be standard, either a standard weight or a standard volume, and then we add that to salt water. And if we just did salt water, it would work okay, but we'll add this salt to make it hypersaline, and we'll do that with DI water and or tap water if we don't have DI water, just because that way we don't have any ocean contaminants, because there's going to be microplastics in that too. And so we make this super salty thing. We're going to shake it up. You have the kids shake it up, and then that shakes loose the plastic particles from the sand grains, and then because of the hypersaline water, they're even more likely to float. So then we leave it for a few minutes, let it settle out, and then we're going to take the floater, so the top skim layer of that water, and we're going to pour that into one of these. So this is one of the few sort of specialty things that you guys need. And so this is just a simple flask, a simple high density polypropylene flask, and it is it's a filter holder. And so the filters that we use, we have different kinds when we use our fancy microscope that have different properties. And there's a lot of research on how to use the best one. Anyway, these are glass fiber filters. So these are relatively cheap. And they're not toxic, they're not plastic or whatever. So they're just these little things you get. And normally these are used in labs to clean water, right? To not so much to collect data, but to just sort of in the prep process kind of thing. So you put the filter on that thing, put that on here, and then once that guy is all shaken up, we're going to pour that water with plastics in it. Are we recording this thing? I forget. Did we? Yeah, it's recording. Okay. And then we're going to put that on here. And if you just left it overnight, it would eventually, all that water would come through, but we don't want to wait that time. So we just have this guy, which is these are super cheap. These are like $20 or something, 20, 30 bucks. So it's hand pump that just is going to, it's going to essentially suck out the air here. The water is going to drip down into this collection container, and then the plastics and whatever else on the top. So you guys will see it when we do the demo. And then we're going to pull off that filter and put it on, and we look around for the filter. And the general approach is, the first thing is, hey, do you guys see any plastics? And then oh my God, and they kind of look around for a bit, and then like, okay, once you got that, then if you want to do the next level, it's okay, beach A, beach B, beach C, which one has more plastic, right? So then they can start to enumerate and count stuff. Again, when we do it in the lab, we have many complex morphologies and color things, and we do all stuff. The simplest thing for you guys is just to say fragments and fibers. So fragments would be part of something that was a much larger chunk of plastic that is degrading and it is breaking down. And so it's a gazillion million shapes. It could be circular, it could be like, roughly circular, it could be oval, it could be square, it could be jagged, whatever. And then the other broad category are fibers from our synthetic clothing. And that's just like little strings, little mini ropes. All of those can be any color. They could be purple, they could be pink, they could be rainbow color, they could be, whatever. So that's basically it. And then these microscopes are pretty, we have a variety, we've tried various ones over the years. The default ones, like these guys, are $80. So, it is $80, but it's not like a couple $100. And again, most of these will plug into either your computer, or nowadays many of them have mini SD cards, so you can record, you can just tape snapshots. So if you get a particularly interesting one, and then you guys could use it in a teaching manual or whatever. Or again, you could throw it up there and show everybody else. And that's basically the idea. So the idea is a density separation of stuff. And sand works really well because sand is, like I mentioned, the clays and the silts, sometimes they hold on to the plastics. There's charges and stuff, and they sometimes hold their charged particles really well. Sand is great. It doesn't hold on very well. And also it's great because everybody likes the beach. Everybody goes to the beach. Sometimes going to the wetland is kind of stinky and like, I don't know about that. But the sand is like, everybody gets the sand. And it's also really more impactful because we usually tell them to go to a place and, just take, you could do whatever, but usually just take your hand and sort of wipe off the top, inch or so of the beach in case something blew on it or whatever. And then take essentially 1 or 2 handfuls of sand is like plenty. And so the act of doing that, they'll be there, and they're like, oh, is there a lot of garbage? Well, there's some bottles over there, but where they're grabbing, it doesn't look garbagey, it doesn't look plasticky, right? And so it's even more impactful when they then look and go, oh my God, there was I thought that was clean sand, but it's got little fibers in it, it's got little, blah, blah, blahs in it. And so that's the basic idea. You guys have any other intro comments to the overall process? Put their fingers in it, start putting the probes in it. Oh, like, look at that. Yeah, totally. Yeah. Yeah, and so, well, that's also a good point. So yeah, it's good to turn that off first. The other is, again, you don't need all these lights, but these microscopes are so cheap these days, but they're really nice. One of the things, and you guys can experiment with this, color is one of the real help. I mean, obviously the shape and stuff, but color is also quite distinctive. A lot of things are blues, are reds, are oranges, and those are great. And those are pretty obvious to see. We get a lot of blue crap and a lot of purple crap. A lot of our clothes are sort of dark colored. So the lights are really interesting. They tend to work best when you do like a sideways light. So you kind of have a bit of a shadow. That kind of helps see stuff. The other thing, which is kind of surprising, is it helps to turn the light down, which might seem counterintuitive. So the way our eyes work, we have, essentially shape, black and white, yes and no cells, and then we have color cells. But those color sensors in the back of our eye are really easily overwhelmed by light. And so if it's too bright, a lot of times you and I will see it as black. And like, oh, there's a black fiber. And you'll see when you start doing this, there's like a lot of black stuff out there. So, whereas if we turn it down, it'll actually, oh, actually that wasn't black, that was blue, or that was purple, or whatever. And so having it a bit lower than, always starting a bit lower than you think is nice. And if we were to do it with like a whole class, or if we're doing this as a long-term monitoring project, we should pick some agreed upon level, like level 5 or halfway in the brightness halfway up or something, just so we're consistent. But yeah, that's basically it. Yeah.
How do you recommend differentiating between fragments and like sand? Because a lot of the times they look very similar.
Yeah, totally. And so so for the purposes of this, it can get really hard. That's another reason why the journals say we have to use our chemical confirmation that really is a plastic to call it a microplastic. So really the short answer is you just got to do it for a while. And after a while you start to get a sense. So so we first started this before we had our FTIR, our fancy color finger printer machine. We'd had that question all the time. Or like, and especially like green. So I think actually, so the worry is that you're seeing something, you're seeing a fiber, a blue fiber, and you're like, microplastic. And the journal people are mostly were like, are you sure? Like, I don't know. Are you sure? It's probably cotton. It could be cotton, right? And so that definitely happens. That we accidentally count stuff that's not plastic as plastic. But I actually think the much greater problem is we're missing a crap load of stuff because there's a lot of browns and greens, and it looks just like algae, or it looks just like seaweed, or it looks just like a piece of sand. So it's true that we want to be accurate on both sides of it. But once you've done 20, 30 of these, you'll start to get a sense. So like the sand, and not that you can't, and it's not perfect, because you can have like a hard piece of plastic that's kind of like sand. But a lot of times the plastic will distend, especially after it's been weathered for a while. So if you take a probe and kind of, poke it, it kind of gives a little, whereas a sand grain wouldn't. It gets really hard if we had like a green film, and you're like, is that seagrass, or is that, so and that's again why for us we just sort of take it, throw it in our machine, and if it comes up as cellulose or it comes up as like biological stuff, we're like, oh yeah, that's not plastic. But the reality is that's just something we have to worry about. And so that also gets to really good technique with this, which is shake the hell out of it and leave it for a long time. We usually with the kids, we usually rush. So it's like shake, 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 leave it for 2 minutes or 3 minutes or whatever. And we tend to have a lot of cross-contamination. The other thing is, the ideal thing would be to leave it for it to get relatively clear, then you have less crap in it. And we'll do it in a second. When we do the demo, you'll get a sense, like you're like, oh yeah, cool, we put it. A lot of that, if it's a really dirty sample, but we also see that with beaches that are really organic rich, so maybe next to a creek mouth, let's say, or something. It's like there's just so many fine little teeny tiny pieces of soil and stuff. It'll just fill up the filter. All the holes in here will get plugged up, and then it takes like forever to get the water through, right? And so one, it's a pain for this, but then also what it does is it makes a huge coating of schmuck over the top. So it essentially buries a lot of the plastics too. So when you get those samples that are really, fine material rich, those are a problem. And what we would do if we were doing that, we would dilute the sample even more times and do it on like 4 or 5 filters, so it's less of a layer. With the kids, we don't really have that luxury. So if that happens, it's kind of like, okay, let's do another sample. So it's probably a good idea to have, just for the heck of it, like a couple buckets of just reference sand in the back, that if that happens, just grab another handful of sand and have them do it. But yeah.
Yeah, this morning, both my samples had a ton of worms and a ton of bugs in it.
Yeah, he had Ryan had very, like near creek mouth stuff, and it was just a lot of like black twigs and beetle larvae and like all that kind of really organic rich stuff.
What beach was that?
It was
One was iron. Was it
Iron Woods,
Iron Woods?
and then the other one, I don't know.
Was it S Street? Was it S Street?
Esther.
S turn. S turn. S turn.
S
S turn.
Okay.
I mean, it's not bad to have like bugs and stuff.
Any
It's
sample
little
you
bits
get
is
is
fine.
probably gonna have something, but
Yeah.
and
Yeah.
for the kids, like for me, when I had like bugs in mine, for the kids, I'd be like, you think the bugs will look like plastic? Like, no.
Yep.
It
Totally.
proves the point a little more.
Totally. Yeah, so like a unit, one of these units, so call one of the microscopes 80-ish bucks, call, this hand pump thing, like, I don't know, things are always more expensive these days, but like, 30, 40 bucks, something like that. Probably the most expensive thing is probably this is sort of a little bit of a specialty thing, but you're probably talking about, 150, 200 bucks for one of these setups, but they'll last you for years and years and years. So it's a little bit of a setup to have like 6 or whatever you guys maybe end up, assuming this is even interesting to you. If we went down this road, it's really cheap to set up. And then essentially the only recurring cost is salt, which is cheap. Oh, that's right, and the filters. So these filters are about, I have to ask Zach because my technician holds my hand and all this stuff. I think these are about 50, come out to about 50 cents a filter. So it's relatively cheap. So it's like, call it $5 for a class. The expendable supply is 5, 10, maybe a 10 if we went through a bunch of stuff, right? So it really is budget friendly. And again, if we were doing this outside, you could do this also, but if we were doing this outside, which maybe you guys could do on like a whatever anniversary day or something, I would just go with hand lenses then because the brightness, we find that the brightness on outside in the sun of the screen, it would work, but it's just harder to see. And as long as you have a good bright light, like a good honk and hand lens is about as good. It's just you couldn't share everybody at once at the same time. Other ideas or other feedback for these guys or other comments? All right, you guys want to try it?
A lot of them like it.
What's that?
A lot of the kids really like it.
Yeah, the kids really enjoyed
They love them.
it. We gotta show the parents too, though.
Oh, totally.
So
Yeah.
take this guy and we pour him in here. That's the first step.
Yeah. Okay. The first step. Okay. So first step is to put about for this stuff, put about 200. So the other nice thing about the mason jars is they have here. Let's do it. Let's do a demo.